Okay, so this is the first execution, friends, and I will share another set of code with you people. Let me check where is the code. Now this is for MLFlow, yeah, MLFlow and credit data set. Credit data set could be a larger data set. Let me see if I can share that over WhatsApp and or here. It's a challenge. Let's try. What's okay. Let's try. Oh yeah, great. Data set is not. We are not able to copy the data set. Oh, okay. 143. Let me see if I can share that in the Zoom itself. Data. I'm trying to push it in okay, it is uploading. The file, dataset file is 143.84 MB. So over WhatsApp, I'm not able to share that. Here in the Zoom, I'm trying to share it. It's almost 50% loaded.
I haven't received any previous data through Zoom, Sharad.
The previous Wine dataset is there directly here. In the LMS itself, you can download the Wine's dataset. Yeah, try and download now the credit card.csv file, which is shared in Zoom.
Where did you share in Zoom? I couldn't see anything here. I didn't receive anything.
Okay. It's not showing yet in that case.
You can't upload in the LMS right now?
I cannot do that. We need to. I'll check. I'll check with the team. Let me explain. The code and the data, the flow of the model. Let me, in the meantime, also check with the backend team. Probably they will. It takes some time to upload because it's a complex system in the backend, and I don't have the permissions. I don't have access to the backend system. I'll not be able to do it. Yeah. Okay. Just take a couple of minutes break. 2 minutes break. Let me check with the backend team if they're Sunday, right? If they're available, I'll just ask them to upload it immediately. Just give me a break, huh? 2 minutes. Yeah, guys, I've shared the information with the backend team. Okay, I received the call. 1 more minute. Yeah, it is done, friends. I've informed the backend team that they're doing it now. So let me proceed and talk about what we are supposed to do. Once they have updated, they will confirm, probably 10-15 minutes. And once they are done, we will you'll also be able to download and do it. Okay, so I've asked unnecessary things to be removed as well. So let me explain the code that you are going to get now. This model. Yeah, this MLFlow.py, which I have already shared over WhatsApp and over here. You can open this file. This file basically is explaining us how to run hyperparameter tuning and then choose the best model, and then we will also be able to save that best model for deployment. We're not just doing the deployment, but the rest everything is being done here. Deployment, we will do it on Azure platform. Okay, so additional code is also given. If you want to run through this code, you can also run through this additional code. But till here, we have the code which is required. So let us go through this. So let me clean it up. All the libraries that are required, we are basically importing all of them: NumPy, Pandas, Matplotlib, Seaborn, sklearn, related things. MLFlow and MLFlow's sklearn. Again, I'm using sklearn version only. You can check what are the various versions that we have imported. I've not imported this. So these are all the different versions that we are using. MLFlow is 2.1.4. Next, we are importing the data set, credits.csv. I'm defining the path and loading the data set. This is not that why. Copy as path. Let's do this here. Okay. So I've changed the path here to point to the directory where the file is placed. I'm loading the data set. I'm calling it as data. Now this data set is large data set. It contains 4,898 rows and 12 columns. And out of these 12 columns, if I say info, all the columns are float data set, float values, except the last one, which is the class. This class is your output variable. The data set is credit card transactions data set. We are saying whether the transactions are genuine transactions or fraud transactions. Just an example data that we're taking. In this, time is not required. It should be a string, but here it is showing us float. So time is not required. We can delete the time. If you want to see the data set, you can just double click this and see the data. Spider is unable to retrieve the value of this format in the console. Oh, why? Strange. Let me say head. Okay. Here it is coming. So you can see time is in some weird format. We will be deleting that here. And then again, you can say head, you will be able to see the data without the file. Something is happening. Then the class that we have, right? The class data that we have is basically numeric data. Okay. So some issue. Look at that. Data set size, it has not loaded completely. Give me a second. Huh? Okay. I've imported the libraries. I'm loading the data set. It should have. Now it has loaded the full data set. Okay. I'm removing the time and I'm saying head. Now I'm getting the complete data. Value underscore counts, it basically gives us the breakup. How many genuine transactions are there? How many fraud transactions are there? Now what we're doing is just to ensure that our example code, right? This is an example code. So in order to ensure that our example code doesn't get bogged down because of the data set size, we are trying to take only a sample of the data set. So here you have 28,000 records, right? Not 28,000. This is 200. What is this? 284,000. Here, if you see, genuine case transactions are 284,315 transactions. It's a very large data set. So what I'll do is I'll take only 50% of this data. Okay, that's here, defining here. So take the data from class equals to 0. That means these number of cases that we have, right? Take only 50% of the data and reset that index. Don't use the same index, reset the index. This way, I'm trying to reduce my total data set size to a smaller data set size. You can see here from 284,000, now I have 142,000. And for anomaly data set, I have only very limited number of records. So I'll take those records as is. 492 records. This is the shape of your data set. You can cross check. Next is I'm partitioning my data set into three parts. One is the train. The other one is the validation data. So first I'll do train test. Using train test, I'll say train and test. Right? This is 20% of overall data, and this is 80% of the overall data. Now this training data set is further getting split into train and validation. So I'll have data set 1, data set 2, data set 3. Right? So load the data set, remove the unwanted time column, take sample data set only from the class 0 so that the data set size is not too much of imbalanced. Then we are splitting the data. So first split the data into train and test for normal data and then anomaly data. That means 0 class and 1 class. Then this data set can be further split into train and validation. Right? So train, test, and validation. 3 different data sets have been captured for 0 class and 1 class. I'm splitting that data into the input and output separately for all the 3: training data set, test data set, validation data set. Okay. So I have train input, train output, validation input, validation output, test input, test output. Right? Three parts we have captured. Then you can see the sizes. These are the respective sizes of your data set. Train data set, test data set, validation data set. Then we are doing the pre-processing. Scalar, I'm using the standard scalar. I'm applying the standard scalar model to the data set, input data set, except for the class. And I'm transforming this on the 3 data sets: train, test, and validate. Right? So doing in your standardization so that the scale of all the input columns is same. Next is I'm trying to define the custom function called train. This is to define the training of the model on the training data set, and we will also be able to score the data on the training data set. We are capturing those metrics. MLFlow.log metric. So when you train your model on the training data set using this model that we are defining, you will be able to train and then record the scores. Then for evaluation, we are using the same SK model, but this time I'm using test data set and evaluating the model. And these are all the different metrics that we are capturing, and visualizations are also being done. Right? We are saving the figure as well. These are the metrics that we want to capture. Using MLFlow, we are only capturing the evaluation score and accuracy score. All right, next. This is where I'm defining my model. So let me run this. I've not run this. Define the custom function. This is the logistic regression model. I'm developing this using solver, max iteration, and random state. These 3 default parameters I'm using. Once the model is defined here I'm starting the experiment. Just say MLFlow.set experiment and run this. Now what happens is in your MLFlow UI, you will be able to see, it's not started yet, but you will be able to see this one, yeah? sklearn experiment 1. I've just started the experiment. Now within this, I'm going to run the model for the first time. So train, I'm calling the custom function, passing the SK model, train data, test data, train input and output. Then I'm doing evaluation and then recording the model. This is the first run. Start run, end run. Now again, we'll go to the MLFlow and see. If I come here inside it, you will be able to see this model. If I click into this, you will have artifacts and all that captured. The images are also there because our code was selecting the images and capturing those images, right? These are the images which are also getting captured. In MLFlow also we are capturing that. These are the parameters. I have not captured any parameters. We have metrics that we have captured. Right, so this is the first execution. I have not captured any parameters. We are only capturing metrics. 3 metrics we are capturing, right? So only those 3 metrics are captured. We can rerun this model once again. This time you can again use an experiment. You don't need to do this. But if you have to map your model, then you are going to map the model like this. Now, what we are doing here is we are not trying to rerun the model. We are trying to load the model. Okay, this is version 1 model only. Sorry, version 1 model loading. So here I have loaded, experimented. Here we are going to take that model, set this experiment, and within this experiment, log the model. Yeah, so this model we are logging it. So it will be called now as, sorry, this is version 2. This will be called as log regression model. So let us go here once again. So this is logging the model. This is just now we have executed. This is the model. The folder that the logged model is this folder. You can see log regression model. So it will create that folder name. ML runs. Here we have what is the ID? Let me show you. UI 38B95. 38B95. If I go to the folder, yeah, this is the model. Now, what we have done is we have logged the model. Right, that means you should be able to see this model logged into the models folder. It's not coming. We have not registered it, right? We just logged the model. We need to register the model and log it, of course. But yeah, what we have done is we logged the model. So it is creating this folder, right? And this folder is basically getting, how do I say? We are basically saying that, okay, this is the model that you might want to now use or register. Okay, we are logging that model. Okay, and we are activating the model run, and you have these details printed here. When you run this, print function is executed, and you will be able to see the result as well. What is the run ID is something that you will be able to see. Okay, so let me run this. This is the run ID. When I executed everything at one go, you basically will be seeing everything printed, and your machine learning function will be stopped here, and this is the version. Okay. So here we have logged the first model. Here we are logging the second model. 2 models we have logged. Now, among these 2 models, I will be able to try and register and then deploy it. Now, what we have done is running a single execution. What if I have to do hyperparameter tuning? So if I have to run through the hyperparameter tuning, then let us try and use it. But yeah, that is the second experiment. Let me finish this. So load model, log model is to register or to save that artifacts into the MLFlow ML runs folder file store. Whereas here, if you see, we are loading an MLFlow model and then executing the results using that model. But this folder has to be changed. This is the run ID that I have to give here. So when we executed this, it is giving us run ID, right? So we just change that folder name. So we want to load the model, but what model you want to load, you have to give that location. And we are calling this as log regression model, right? So we are giving that name as well. So when I do that, I get the linear regression model, which is trained here. Using that, I will try and do the prediction. On the test data set, if I'm testing it, how does it work? It is giving us 99.87% accuracy. All right, so this is basically how we do the training and loading.